Let's discuss the situation where an outdoor light unexpectedly activates when a fan switch is turned off. The core issue likely revolves around the neutral wiring within the switch box where both the fan and the outdoor light are controlled. When the motion or sensor unit was disconnected and replaced with the standard pigtail socket and incandescent lamp, the original behavior involving the fans was maintained. This points away from the motion sensor or photocell as the primary cause. The first potential problem stems from a shared neutral connection. It's common to find multiple neutral wires bundled together in a switch box. If the neutral wire for the outdoor light is improperly connected or sharing a connection with the fan circuit, turning off the fan switch can inadvertently interrupt the neutral path for the light. This interruption, rather than an arc or signal from the fan switch, is what causes the light to activate. To understand this better, let's consider how a basic electrical circuit works. Electricity needs a complete path to flow from the power source through the device and back to the source. This path consists of a hot wire, which carries the electricity to the device, and a neutral wire, which provides the return path. If the neutral path is broken or interrupted, the circuit will not function correctly. In the case of the outdoor light and the fan sharing a neutral, turning off the fan switch can create a situation where the neutral path for the light is momentarily interrupted. This interruption can cause a voltage fluctuation or other electrical anomaly that triggers the light to turn on, even though it shouldn't. To resolve this, it's essential to examine the wiring in the switch box carefully. Firstly, ensure that the neutral wires for the fan and the light are properly separated and connected to the neutral terminal or bus bar in the box. A pigtail connection is often used to create a dedicated neutral connection for each device. A pigtail involves connecting multiple neutral wires to a single wire, which then connects to the neutral terminal. This ensures that each device has its own independent neutral path. Secondly, double-check that all wire connections are secure and that there are no loose wires or frayed insulation. Loose connections can cause intermittent problems and can also be a fire hazard. Thirdly, consider using a multimeter to test the voltage at the light fixture when the fan switch is turned off. This can help to determine if there is a voltage fluctuation or other electrical anomaly that is causing the light to turn on. Now, let's address the second part of the situation, why the room lights in the bathroom or laundry room have no effect on the outside light. This is most likely due to the photocell that is built into the outdoor light fixture. A photocell is a light-sensitive device that automatically turns the light on or off based on the ambient light level. During the day, the photocell detects sunlight and keeps the light turned off. At night, when the ambient light level drops, the photocell turns the light on. The photocell is designed to prevent the light from turning on during the day, even if the switch is turned on. This is because the photocell is more sensitive to ambient light than to artificial light sources. Therefore, the room lights in the bathroom or laundry room are unlikely to have any effect on the outside light because the photocell is already sensing sufficient ambient light and keeping the light turned off. If the photocell is malfunctioning, it may not be able to accurately detect the ambient light level, and the light may turn on or off at inappropriate times. In this case, the photocell may need to be replaced. Another possibility is that the photocell is not properly positioned. If the photocell is blocked or shaded, it may not be able to detect the ambient light level accurately. In this case, the photocell may need to be repositioned. To summarize, the activation of the outdoor light when the fan switch is turned off is likely caused by a shared neutral connection or other wiring issue in the switch box. The room lights in the bathroom or laundry room have no effect on the outside light because of the photocell and the outdoor light fixture. To resolve these issues, carefully inspect the wiring in the switch box, ensure that the neutral wires are properly separated and connected, and check the photocell for proper functioning and positioning. Furthermore, it's worth noting that electrical codes and best practices emphasize the importance of proper grounding and bonding. Grounding provides a safe path for fault current to flow back to the source, helping to prevent electrical shock hazards. Bonding ensures that all metal parts of the electrical system are electrically connected, reducing the risk of voltage differences that could cause a shock. When working on electrical systems, it's crucial to follow all applicable codes and safety guidelines. If you are not comfortable working with electricity, it's best to consult a qualified electrician. Let's delve a little deeper into the function of a photocell. A photocell, also known as a photoresistor or light-dependent resistor or LDR, is a passive electronic component whose resistance decreases with respect to increasing incident light intensity. In other words, it exhibits photoconductivity. A photocell is made of a high-resistance semiconductor. If light falling on the device is of high enough frequency, photons absorbed by the semiconductor give bound electrons enough energy to jump into the conduction band. The resulting free electron and its counterpart, a hole, conduct electricity, thereby lowering resistance. If light falling on the device is of low enough frequency, photons absorbed by the semiconductor do not give bound electrons enough energy to jump into the conduction band. The material behaves as an insulator. Photoresistors are light-sensitive devices most often used to indicate the presence or absence of light, or to measure the light intensity. The NEC, or National Electrical Code, addresses requirements for outdoor lighting and photocell control. While the NEC doesn't mandate the use of photocells in all outdoor lighting applications, it does provide guidelines for their installation and use when they are employed. For example, NEC section 210.70 subsection A paragraph 1 states that at least one wall switch controlled lighting outlet shall be installed in every habitable room and bathroom. While not directly related to photocells, this section highlights the NEC emphasis on providing readily accessible lighting controls. NEC section 210.70 subsection A paragraph 2 requires at least one wall switch controlled lighting outlet shall be installed at stairways, hallways, and at entrances to buildings. Again, this underscores the importance of having convenient lighting controls, which can work in conjunction with photocells in outdoor lighting scenarios. NEC section 410 covers requirements for luminaires, lamp holders, and lamps. This section may contain information relevant to the physical installation of outdoor lighting fixtures that incorporate photocells. For example, it specifies how fixtures should be mounted, wired, and grounded. NEC section 725 deals with Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. If the photocell circuit is a low-voltage or power-limited circuit, this section may apply. Keep in mind that the NEC is a comprehensive code, and specific requirements may vary depending on the application and local interpretations. Always consult the latest edition of the NEC and local codes for the most accurate and up-to-date information. In addition to the NEC, there are other relevant standards and guidelines that may apply to outdoor lighting and photocell control. These include standards from organizations such as the Illuminating Engineering Society or IES, which provides recommendations for lighting levels and design practices. Local building codes and ordinances may also have specific requirements for outdoor lighting, such as restrictions on light trespass or energy efficiency standards. Regarding troubleshooting the neutral wire issue, it's crucial to use a systematic approach. Firstly, turn off the power to the circuit at the breaker box before beginning any work. This is essential for safety. Secondly, carefully examine the wiring in the switch box, paying close attention to the neutral connections. Thirdly, use a multimeter to test the voltage at the light fixture when the fan switch is turned off. If there is a voltage present, it indicates that there is a problem with the neutral wiring. Fourthly, try disconnecting the neutral wire from the fan circuit and see if this resolves the issue. If it does, it confirms that the fan circuit is interfering with the light circuit. Fifthly, if the problem persists, try replacing the switch for the light fixture. A faulty switch can sometimes cause unexpected behavior. In some cases, the issue may not be a wiring problem, but rather a compatibility issue between the fan and the light fixture. Some fans can generate electrical noise or interference that can affect the operation of sensitive electronic devices like light fixtures. In this case, try using a different type of light fixture or installing a filter to reduce the electrical noise. When dealing with electrical issues, it's always best to err on the side of caution. If you are not comfortable working with electricity, consult a qualified electrician. Let's consider some additional factors that could contribute to the issue. One possibility is that the wiring in the house is old or damaged. Over time, wires can become brittle or corroded, which can lead to electrical problems. If the wiring is old, it may be necessary to replace it. Another possibility is that there is a ground fault in the circuit. A ground fault occurs when electricity flows to ground through an unintended path. Ground faults can be dangerous and can cause electrical shock. If you suspect a ground fault, consult a qualified electrician immediately. It's also important to consider the type of light fixture that is being used. Some light fixtures are more sensitive to voltage fluctuations than others. If you are using a light fixture with electronic components, it may be more susceptible to problems caused by voltage fluctuations. Try using a different type of light fixture to see if this resolves the issue. One more thing that may be helpful is to document all the steps that you have taken to troubleshoot the problem. This will help you to keep track of what you have tried and what has not worked. It will also be helpful if you need to consult with an electrician. In addition to the electrical aspects, consider the physical environment around the light fixture. Excessive moisture or humidity can sometimes affect electrical components and cause them to malfunction. Ensure that the light fixture is properly sealed and protected from the elements. Also, check for any signs of insect infestation or rodent damage, as these can also cause electrical problems. If the issue occurs intermittently, it may be helpful to monitor the circuit over time to see if there is a pattern. For example, does the problem only occur during certain times of the day or under certain weather conditions? This information can help to narrow down the cause of the problem. Remember to always prioritize safety when working with electricity. Turn off the power to the circuit before beginning any work, and use caution when handling electrical components. If you are unsure about anything, consult a qualified electrician. Let's also talk about the importance of using the correct type of wire and connectors for electrical work. Using the wrong type of wire or connector can create a fire hazard. Make sure that you are using wire and connectors that are rated for the voltage and amperage of the circuit. Also, make sure that the wire and connectors are properly installed. If you are not sure how to install wire and connectors, consult a qualified electrician. And for clarity, amps are a measure of electrical current, and volts are a measure of electrical potential difference. Understanding these units is fundamental to electrical troubleshooting. It is also important to have a clear understanding of the National Electrical Code, or NEC. The NEC is a set of standards for safe electrical installations. The NEC is updated every 3 years, so it is important to make sure that you are using the latest version. The NEC is available from the National Fire Protection Association, or NFPA. It may be helpful to review the relevant sections of the NEC to ensure that your electrical work is in compliance with the code. In the situation described, the issue of the fan switch affecting the outdoor light could also be related to harmonic distortion in the electrical system. Harmonic distortion is a phenomenon where the current and voltage waveforms in an electrical system become distorted, typically due to nonlinear loads such as electronic devices, including some types of fans. These distortions can create unwanted electrical noise and interference that can affect other devices in the same circuit. While less common in residential settings, harmonic distortion can sometimes cause unexpected behavior in lighting systems and other sensitive equipment. If you suspect harmonic distortion may be a contributing factor, it's best to consult with a qualified electrician or power quality specialist who can perform measurements and analysis to determine if it is present and how to mitigate it. They may recommend installing harmonic filters or other power conditioning equipment to improve the quality of the electrical supply. Now, let's consider the possibility of electromagnetic interference, or EMI. EMI is a disturbance generated by an external source that affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. EMI can disrupt, obstruct, or otherwise degrade or limit the effective performance of the circuit. In the context of the outdoor light and the fan, it's possible that the fan motor is generating EMI that is affecting the light fixture, especially if the light fixture contains sensitive electronic components. To mitigate EMI, you can try the following steps. Firstly, ensure that all electrical connections are tight and secure. These connections can act as antennas and radiate EMI. Secondly, use shielded cables for the wiring to the light fixture. Shielded cables can help to block EMI from entering the circuit. Thirdly, install a ferrite bead on the power cord of the fan. A ferrite bead is a small magnetic device that can help to suppress EMI. Fourthly, move the light fixture away from the fan. The farther the light fixture is from the fan, the less likely it is to be affected by EMI. If you have tried these steps and the problem persists, it may be necessary to consult with an electrician or an EMI specialist. As a last reminder, always follow safety precautions when working with electricity. Turn off the power to the circuit before beginning any work, and use caution when handling electrical components. If you are unsure about anything, consult a qualified electrician. And always adhere to local electrical codes and regulations.